Welcome back, everybody. Tonight we're going to use the plasma cutter and actually cut the stainless steel. I'm going to show you a few tricks and techniques to doing that process. I just wanted to reiterate the fact of the safety. Make sure that you have ventilation, protection for your eyes, hearing, fire suppression, any of those things depending upon the area that you're working. So I'm going to start out by just taking the panel. I'm going to make a couple of measurements, and when I take those measurements, I'm going to put a piece of material on there so I'll have an area to rest my standoff guide. Now, you may not know what a standoff guide is, but depending upon the type of plasma cutter that you have, they will have something that goes onto the torch, and it will mount on there, and it will give you an edge, and that edge allows you to guide it along something. So on this particular type of plasma cutter, they're very small. They actually fit right onto the air cap that's on the top of the cutting torch itself. It works out really well. I've had others that clamp on. They get a little bulky. They actually clamp onto the torch body, and they get in the way when you're trying to come around turns and things of that nature. But this one it does work pretty well. Plasma cutters themselves. There are different types of plasma cutters. There's inverter style. There is different types of the way they start. Some of them have an arc system, a self-starting arc system that's built in, like a hypotherm or in this particular one. Some of them short to ground to start. Either way, they're all good unless you're using them on some specific electronic equipment. I know that in the past we tried them on a what you call a plasma cam or a two-dimensional electronic cutter, and you put them on there, and there was some RFI, radio frequency interference of some sort. Some people will call it electromagnetic energy interference, but the bottom line is it interrupts the square signal that the machine operates on, and then your cutting isn't accurate. So you want to make sure that you have none of that going on wherever you're working. So you know that we have a lighting panel. We've gone from a template. We've cut it out of a piece of sheet stock. So I found some old ones that I've had on some different vehicles. I even brought in a piece of aluminum. I'm going to show you. This is an aluminum diamond plate, my second favorite metal. But we are going to talk. We're going to actually do some cutting. So the first thing you're going to want to do is you're going to want to find something like a straight edge, something that you can work on. That will help you with that standoff guide. Now, not everybody has to use a standoff guide. There are times that I cut that I do not use a guide. Sometimes I can freehand things. It depends upon how long of a run that I'm making and how accurate it needs to be for what I'm doing. In this case, in a lighting panel, you're going to want it to be very accurate. So you want to keep the tolerances as close as you can. The plasma cutter is going to need compressed air. They make them that run on nitrogen, argon, hydrogen. It's endless for what you want to spend. But the ones that I purchase, I use compressed air. The compressed air needs to have somewhere around 75 pounds per square inch maintained at all times while cutting. The air also needs to be clean and dry. That can be difficult depending upon the type of compressor that you're using. You may want to put a filter dryer or an oil separator, things of that nature, on the air line if you're having trouble with that. But I just thought I would mention that because I have, over the years, experienced troubles with different air systems with different equipment. So I actually choose something like this. It's the bottom of a door. It's an old aluminum piece. I like it because it's flexible a little bit. It's not very high, so like if I mount it, it enables my torch guide to not interfere with the torch body as I'm sliding along. So I can cut a pretty straight line with it, fairly accurate depending upon how well I do the measuring and marking. Something else that I wanted to mention, you got to remember that there's kerf width that's going to come out of the material that you're cutting. And what do I mean by that? Well, if you took anything, if you took a stick of butter and you put it on the counter and you divided the butter in half, when you take the knife and you slowly go to the cutting board and you split the butter in half, whatever that knife removed from the butter is a kerf width. Okay, a lot of people don't realize that. A lot of mistakes are made like on a chop saw when you're shearing something in half. And somebody may say to you, I have a piece of 8-foot material and I want two 4-foot pieces. So you go over and you go to cut them, and when you cut the middle of it, you no longer have 8-foot or 4-foot pieces on either side. You have whatever the kerf width was of the cutting device that you used. In this case, the kerf width can range up to almost 1/8 of an inch, depending upon what type of material you're using. Sometimes with the aluminum, it gets to be a little bit more, depending upon the heat range and how much air pressure you're supplying the machine. So stainless is interesting because it can be difficult to cut at times. A lot of you may or may not know, but stainless steel is basically a mild steel, an A series, and then they add chromium, nickel, and a couple other properties to it, and then that floats to the top when they're making it, and that is what hardens it, and that's also what makes it non-stainable. So you need to know that when you're cutting, because you're going to have slag or what we call porosity or materials that stick to the torch that make it probable that you need to clean it more often so that you can keep getting accurate cuts. So now that you know that, you know about the number 5. Oh no, I'm sorry, we didn't talk about the number 5 lens. So when you're working, we talked about safety glasses in the last video. I think this is a new safety item that we're going to mention tonight. The number 5 lens will protect your eyes from the flash, from the high temperature of heat, as far as what it can do to your retina and so forth. So you want to protect your eyes. So like a welding flash, if you know a little bit about that. Now, when you're younger, you may want to use something a little bit more, a little stronger. I know 25 years ago, I could use probably around a number 8. Number 10 I could get away with if I was outside in the sunlight. So in that case, you could use just a standard welding helmet if you wanted to. And if you used something like this with a panoramic view, and then you use something with an adjustment series in it so that you're able to adjust the shade of the lens, the time that it turns on, you can get something that is fairly accurate for your eyesight. So just to mention that. Okay, so I'm going to put my reading glasses on first so I can see. All right, and what we're going to do is we're going to take the torch itself. We are going to try to take a ruler, and what we're going to do, there are more accurate ways to measure this, but I'm just giving you a general idea tonight. So I'm going to take that across the ruler, and I'm going to check to the center, and it looks like it's approximately 3/8 of an inch from the standoff guide to the center. Now, something else on this particular one, something else I want to mention. Every time you rotate this or you turn this torch tip to get out of your way for whatever it is that you might be doing, it could change the area or the space between the ears, and that will affect your overall cutting if you want to stay on a particular line for some reason. You'll notice I have a couple of these. I have a little kit that's got, extra parts for the plasma cutter. They're called consumables. You're going to go through quite a few consumables if you're cutting all the time. I keep more than one standoff guide present at all times because I'm cutting so many things. Sometimes they get damaged. Sometimes I'm not happy with the exact alignment, and I want to change it. So, all right. So I've taken the liberty already to just make a couple of marks. I'm going to give you a straight line, as straight as I can on this piece of material tonight. So you always want to clamp your material to a work surface so it's not floating around on you. And then I'm going to take, what I did is I measured in about 1/2 of an inch from both ends. This piece is short enough so that I made a couple of dots with my Sharpie. They also make different color Sharpies, as you probably know. Different materials, like if it's a darker material, I use the silver type one. It works really well. They also make some welding pencils that work well. If you're going to follow a line, the heat won't melt them. And then, of course, from school, you know about the soapstone that we use on mild steel. So we're going to line this up. Then we're going to get a couple of clamps, okay? Just C-type vice grip clamps. You can pick them up just about anywhere. And I like to go around this so it's out of my way. I look down the other end. I'm going to line it up as close as I can on the line. Make sure the other end is close. Because I can readjust that one, but I can only do one at a time. Okay, that one there. And that one there. All right, now you're going to notice that this edge is beveled up. It's not sitting flat. Remember, I didn't use a piece of flat stock. I took something that had a little radius to it, something that was a little bend to it, because that allows me to follow along with my standoff guide nice and even. Okay, now you can notice if I want to change positions, I can. Now, this is going to make a little bit of noise. It is going to cut. It's going to throw some sparks. You do need to watch out for your feet also. You need to have protective shoes on when you're doing this, or at least be aware of it. Okay, so the next step is to make sure that you've got your machine on. You want to, if you're cutting stainless, even though this machine can sever up to 1 inch and cut to 7/8 of an inch is what it's rated for, when we operate on stainless steel, we're going to want to turn the power up as high as we can, because it will not burn up the consumables as fast. So we're going to do that. All right, we've done that. We've turned the machine on. We have set our air pressure for 75. Okay. Now, there is one thing I'm forgetting here, and I did mention that. You've got to make sure that you've got your ground on your workpiece. When we're in class, I talk about that all the time. I talk about that with the TIG welder, the MIG welder, any of the processes that we're doing. You're going to want to make sure that that ground is on your workpiece. A lot of people will put the clamp on the piece that they're cutting off. Remember the kerf width? And then the piece is going to drop. Well, when that part comes off the table, if for some reason you happen to have damp feet, or you're not on the right surface, or something like that, you could have an electromagnetic shock at that point. It's possible. So I like to prevent anything like that from ever happening. So I always like to make sure that my ground is on the actual workpiece. Okay, so we've got a good solid ground. We've made sure of that. So we've got our standoff guide in place. We've got a good solid ground. We have the part clamped to the table. We have our number 5 lens protective eyewear. And now I'm going to put on my protective gloves. Okay. We made sure that we have nothing flammable on the floor. We are good and ready to go. Are you ready? All right, we're going to make our first cut. There is a little torch handle with a little button on this one. Some of them have triggers, but always be careful so you're aware of which way and how to operate the torch. Okay, now, something else I should mention just before I go. That edge needs to be somewhat smooth and clean. Therefore, it doesn't run the torch down it like a jagged edge. You want it to run down straight and even. Okay, here we go.